Hello, student. I hope you are happy and enjoying the mathematics. Today we'll discuss set in intervals. Intervals can be categorized in two ways: finite interval and infinite interval. Finite interval further may categorize in open, close, and semi-close. Let us start from the finite interval. The subheading is open interval. Open interval. Open interval. Open interval. Right? Okay. The set of all real number lying between A and B is said to form an open interval. Okay. The set the set of all real number all real number lying between lying between lying between A and B, A and B is said to form an open interval. Is said to form an open interval. Interval. Okay. A, this one. Inside this small bracket you write A comma B. This is the symbol of open interval. You may write also like that, or A comma B. Both convey same meaning, right? Okay. Symbolically you can write this in the form of set. Symbolically you can write this edge A comma B means open interval A of A comma B equal to, in builder form, x such that x belong to a real number and value of x greater than A and less than B. So this is the builder form of this interval, open interval A comma B. Now graphically, how we can represent this open interval? Means graphical representation of this open interval. Graphically, right? Minus infinite plus infinite means positive infinite. This is A and B. A and B. A, B means excluding A and B. Excluding A and B, this represent close open interval of A comma B, right? Let's understand by help of the example. Example 2 comma 3 means open interval of 2 comma 3 equal to x such that x belong to R, comma the value of x greater than 2 and less than 3, excluding 2 and 3. Is a set of all real number. This means is a set of all real number lying between lying between 2 and 3. 2 and 3, excluding endpoint 2 and 3. Excluding endpoint and point 2 and 3. Now come to the next one, closed interval. Closed interval, right? The set of all real number lying between a and b, including a and b, is said to form a closed interval. Okay, the set of all real number of all real numbers lying lying between a and b, a and b, including a and b, including a and b, a and b, said to form a closed interval. Said to form a closed interval. Okay, denoted by this, means the big bracket between a comma b. So this is the sign of closed interval, right? Symbolically you can write, means in set builder form you can write symbolically you can write a closed interval of a comma b equal to x such that x belong to a real number, the value of x greater than equal to a and less than equal to b, right? And graphically you can write like h minus infinite plus infinite, right? This represent a, this represent b between minus infinite and plus infinite. So this is the graphical representation of a and b, including a and b, means I will include a and b, means I will dark this circle. This is okay. Let us understand by help of the example. 2 comma 3, close interval of 2 comma 3 equal to x such that x belong to r, means the value of x greater than equal to 2 and less than equal to 3, right? Okay, now come to the third one, semi-closed interval. Semi-closed, or you can say semi-open interval. Semi-closed oblique semi-open intervals. Semi-closed oblique semi-open interval, right? If the number A is included but B is excluded, we say that the interval is closed on the left and open on the right. and is denoted by the sign of half closed and half open. Let us see. I'm writing a definition. If the number A is included, if the number A is included, but B is excluded, but B is excluded, we see that we say that interval is closed on left, closed on left, but open on right, open on right. It is denoted by it is denoted by it is denoted by close on left, open on right by this symbol. This is a close sign of this is a close symbol and this is open symbol. You may also write this like H, or close on left, open on right may be written by this symbol as well as, right? Both convey the same meaning, right? Okay. How we can represent this symbolically? Let us see. Symbolically, SYMBOLICALLY. Symbolically you can write close in left and open in right equal to x such that x belong to R, comma, the value of x greater than equal to A but less than equal only less than B because it is open in right. Okay, graphical representation, graphically you can write like that. Okay, plus minus infinite, positive infinite, A and B, because it is closed in left and open in right. You will not dark this one because it is open on the right, right? Okay, let us see by help of the example 2 comma 3 equal to x such that x belong to R, comma, the value of x greater than equal to 2 and less than 3, right? Now come to the infinite interval. Come to the infinite interval. Infinite interval. Infinite interval. Intervals. Okay. Let A belong to R. Let A belong to R. Right? The set of all real numbers such that x greater than A forms the interval. Set of all real numbers such that x greater than A forms forms a to infinite since x greater than a. Okay. In second case, this forms x greater than equal to a forms this forms close in a but open in infinity. Like as x in third one, this forms x less than equal to a forms the intervals like h means close less than a means open in minus infinite close in a, open in minus infinite and close in a, right? Set of all real number form this interval. Set of all real number, set of all real number form this interval minus infinite to infinite, open intervals of minus infinite to infinite. I hope, my dear student, you will understand this and you will enjoy the mathematics. Thank you very much. Have a nice day ahead.